Hey, everyone. Okay, so I know I've got one person waiting for me at least, and I'm just going to crack on today. I want to make it as quick as possible. So we're going to be focusing on just making sure that you guys are okay with practicing papers, and I'm just here to offer some advice on some of those more tricky questions. I'd love to just going to check that all the sound's working. Yeah, it's all working fine. That's great. I'm just going to change the settings on my other laptop. Hey, Ira. Oh, it's so good to see you. Oh, hey, Marella. Hi. Oh, guys, thank you so much. Girls, thank you so much for coming. I was really worried that I was going to get here and be like, no one's here. No one wants to watch my webinars. Hey, Evelyn. Yay. Oh, it's a regular party now. It's a regular party. I'm just suddenly realizing you'd still see me. Right. Wait, there's register. Yeah, Emmeline, I'm just logging the people who turn up. I know that seems a bit strange. It is just me kind of I just think it'll be good for me to be able to show that people are attending additional kind of sessions at home, and I'll be able to provide the evidence with it. That's all. It's not a big deal if people don't turn up. I'm not fussed if they do, and all I need for them to do is just post onto the chat just a little message. Hey Liz, it's lovely to see you. So guys, have you all had a go at the 2015 paper, the regional? I set that one for week 1. Thank goodness I did. I'm here. Party is now better than usual. Who's that? Who's Ira? Ira? I don't know you. Is this somebody that I should know? That's really funny. Right. I'm gonna crack straight on with the paper. I'm gonna see how much I can get through in the hour. Nope. Fair enough. And by the way, thanks very much, Ira. Is it Ira? Ira? I think it might be Ira. Irina. Oh, Irina! Hello! Oh, I'm glad you made it. Thanks, guys. I still need to revise a lot more. I know, and you know what? This is just me giving you a helping hand with that, Ira, that's all. So I'm hoping that this will be useful. I'm going to see how much of the paper I can do in an hour. I've done it as part 1, part 2, and then I'll do paper 2 in one block. But I am just aware that the paper 1s are long, really long. And so I might break it up into 2. We'll just have to see how far we get. As I said, I really definitely don't want to exceed an hour. I may try and do 45 minutes. See if I can get halfway through. 15 questions on the 2015 regional. Let's see if I can get to 8 within 45 minutes. That'd be interesting. Right, I'm going to crack straight on then. But guys, thank you so much for coming. It's so nice to see you all. It really is. I hope you're all doing well and are safe. Right, let's get rid of my ugly mug. Let's do that. Let's just put that up full, and then cool. So that's all running now. So if I go straight to this, cool. Right, Tom, great to see you, Tom. Thanks for coming. It's good to see you, dude. Great to see you. Great to see you, Tom. Right. Oop. Sorry, power came out. There we go. Right. Okay. So this was the paper that I think you should have had a look at. So this is the 2015, and I put this, I don't know whether or not I've got this open. No, I don't. I've got the mark scheme, by the way, open. I'm not going to use it. I'll use it when I need to. Whenever I feel like I need to take that moment of looking at the mark scheme, I will, of course, do so. If I just change that over to my school account and then have a look at it, I just want to quickly check that I'm doing the right paper. Maybe you guys can give me a heads up and let me know whether or not it is. Just going to quickly check. So I labeled it on the document on the past paper sheet. I labeled it as week 1 and week 2, I seem to recall. Yeah, there you go. Easter week 1, 2015 region question paper. Let's just click that and make sure I've got the right one open, because it would be hilarious if I didn't. Just going to quickly check. Yep, that looks like I've got the right one. Fab. Okay, so let's crack on then, folks. Okay, so I'll do my best to try and make sure that I've got all chats up so that I can see where you guys are with the chats and whatnot. There we go. Okay, so complete the diagram. So starting off at a really nice low level. So we're starting off at a, oh, there we go. Starting off at a good love 3. I nearly actually wrote love. Level 3. Level 2, 3, maybe even level 1. Mayang, hi. Oh, sorry. What? Oh, sorry. I am Sian, old account. RIP. Oh, hi, Sian. Nice to see you. So it's starting off nice and low. Love 1 to 3. This is really a love 1 and 2, really. Yeah, a level 1 and 2. And we're drawing a gas. So I'm just going to, now the awkward thing here is that usually when I have this particular situation, I like to count the particles in the liquid and then turn them into a gas. They've deliberately done this to make this a little bit more tricky. Hey, Sophia, it's great to see you. Thanks for coming. To make this a bit trickier, because if you had 5 particles and there was a liquid, I would have translated 5 particles into gas. But considering it's a full screen as a liquid, I'm very aware that I just need to put on a whole load as particles, as gases. So I'm just going to do 5. It'll be interesting to actually look at, see what the minimum number is on the mark scheme. I'm going to say it's probably about 5. You can of course add a few more if you're ever in doubt. As long as, well, I've given them a nice order there. Didn't want to do that. Lol. There we go. I'll do. And I'm going to do kind of moving around. Yeah, it's always nice to show that. It's a bit thick, that, to be fair. But whenever I like to draw gases, I am very aware that I do like to kind of them being random. Yeah, it's usually a follow-up question, kind of describe the motion and the energy of the particles. Mr. Duncan can't count. It says 4. What says 4? What? Oh, does it say in the question 4? Oh, yeah. Oh, it says 4 particles in a gas. Oh, no. RTFQ. Read the full question. There we go. There we go. Try and make them the same size as well. Always useful. There we go. RTFQ, read the question. It's really easy to miss that. It says 4, brain pain. It's been I've been on lockdown now for a long time. I'm feeling a bit closed in, Emmeline. It's freaking me out. Describe the movement of the particles in a gas. Ooh, random. So that one word, it'd be interesting. Particles are moving. Now, by the way, boys, level 1 chem guys, I know, and I've just made a mistake. Can you believe it? Can I just say boys here? Please, please, please. The mark scheme will probably just have that word, yeah, as a random, not random, I've lost my mind, random. They probably will just have that mark on the mark scheme, but I am just going to say that you should never ever give one word answers. Particles moving, I just don't trust particles moving in all directions. All directions randomly. Oh, is this thing still on full power? If it is, that's going to be very depressing. Let's see if I can close something down. I bet I can't. If I close that, and I close that, and I close maybe that one. There we go. Try and make it as... yeah, I'll do. Okay, let's try that. See if that goes a little bit better. I wonder if there's anything else running. Don't think so. Just the Bluetooth, which is a little bit... I don't know why it's running quite so slowly. And then I'm going to put random. Wow, it really is struggling a little bit today. I might have to fix that. Explain why heating a liquid causes it to evaporate more quickly. Oh, guys, that's a really horrible question because that's rates. I can't even say deteriorating. Oh yeah, with you. That took me ages to read that with all those capitals and funny places. Explain why heating a liquid. This is a rates question. Yeah, this is not a standard. That's a bit of a step up. That isn't that interesting. My laptop really is struggling, and I don't quite know how to sort it out. Maybe if I turn off my Bluetooth. I don't know how to do that. Actually, no, I do. Let's do 2 things connected. Let's turn that off and see how that gets on. Yeah, it's partly because the paper's so big. This little laptop is a little limited on its power. But this, anyway, going back to the question, this is a rates question. And so it explains why heat in a liquid evaporates more quickly. So this is going to be running kick-ass. Yeah, we've heated it. This is a kick-ass question. That's quite clever, that. It's still going to be a low level. They're going to say knowledge. Particles have more kinetic energy. Particles have more energy. They will just allow you to say more energy, but it is nice to say the word kinetic. You know, it's always good to give that kinetic energy. And then we're going to say collision theory. Oh, we don't really need the collisions because this isn't about a reaction. So collisions isn't needed. Activation, yes, more particles. You're not going to say activation energy though. More particles have enough energy. It's really weird how my laptop's behaving. More particles have enough energy to overcome bonds. Hence why it evaporates more quickly. Very interesting what my laptop's doing. It's doing something very odd things. There you go, to overcome bonds. That's a very interesting question now, folks. You don't need successful either, but you do need those two. That's what it's going to be. It's a really clever rates question in reality. Particles have more kinetic energy. More particles have enough energy to overcome the bonds. That's what boiling is. Please, can you explain what kick-ass is? Yes, of course I can, Irina. So in rates of reaction, what we realize is it's all about this idea of if you take 2 particles, A and B, and we want them to react, what we realize is, and they're going to create something like that, in order for this reaction to happen, you've got to consider certain pieces, and you'll recognize this. You'll recognize that what you have to consider is, number 1, you've got to consider the knowledge. And the knowledge is about what we're changing in the question. So this one is question based. So if at least we give a question of Q1 of increased temp, which we've just done, increased temp, that's what the question we've just had is. This stands for knowledge. And the knowledge comes from the question. Kick-ass is a method, by the way, that I teach for students to obtain full marks in rate questions, Irina. So knowledge here is particles have more energy. It's really weird how my laptop's really struggling. Parts have more energy. Particles have more energy. Shouldn't say parts, really, should I? Particles have more energy. I don't know what's going on. Have more energy. Kinetic, if you wish. I honestly don't know why my laptop is having such a problem. How particles have more energy. And then kick-ass, which is C, which is collisions. The C stands for the frequency of collisions, how often they collide. My laptop is really, really struggling with this today, folks, and I have no idea why. This is collision frequency. I don't know how to speed this up, but it's really struggling. Maybe if I eject that one. All I'm trying to do is I'm just trying to free up a little bit of memory. And the laptop's just struggling a little bit. I'll have to play around with this later on. This is collision frequency. Yeah, how often they're colliding. And we would say increased collision frequency. Yeah, increased I'm just going to do that just to save the time of writing it. Collision frequency. And then the A stands for activation energy. Activation energy. And this is just the number of particles who have it. Yeah, number of parts with activation energy. So we've got more particles. More particles. No idea why my laptop is being so horrendous today. More particles with activation energy. I'm just going to put EA there, just to save me the time. Hey, Julian, great to see you. And the last one is, this is probably the most lost mark in this particular topic arena, successful collisions. So can I just point out that these are not the same as this? Students think that the successful collisions is the same as the collision frequency. They're not. They're independent points. There are more successful collisions. More successful collisions. I'll put cols, same at the time. So it's just a method that I run, Arena. If you want, have a look at my webinar on rates of reaction and it'll explain it to you. All right, next question. Straight into organic at this point, folks. The diagram shows the separation of crude oil into its fractions. Name the method. All right, so this method of separation is fractional distillation. Yeah, you are not allowed to just say distillation. You have to say fractional. They are not the same thing. Still, my laptop killing me. I'll have to play around with it and fix it. There we go. Do you know what I'm tempted to do? Tempted to. See, look at that. Look how slow it's running. If I do devices and then go, no, it's not going to give me what I want. I want device manager. Blimey. Really struggling. Device manager. I'm just thinking that I might be able to, if I turn off my, turn off the camera's running simultaneously to this. It doesn't actually shut it off for me. So if I just shut all those off, not responding. Look at that. It's really struggling. Don't know why. Go figure. Device manager, I think it probably needs a restart. Oh, there you go. There's the waiting one. Let's disable that for a minute. Just disable device. Yes. So what that'll now do is it should free up a little. See, it's not running anymore in the background. Hopefully that'll give me a little bit more memory. We'll see. We will see. Right, complete the table by giving the correct fraction A, B, C, D for each of the descriptions. Oh, only contains gases. Right, so you've got to know these fractions a little bit, guys. And this time it's only giving you 6 instead of 7, which I think is quite interesting. The gases one is A, all gases, natural gas. Next one, which is the most viscous? Oh, F for sure. Yeah, and then of course, which contains bitumen, which is F as well. So that one there is the one that everyone worries about. They're worried about the fact that, well, you've got to know all the fraction names. Yes, guys, I'm sorry, you do. Unfortunately, this is correct. You do have to know all of the fraction names. And so just make sure that you've practiced them. It's in your exercise books. I've given you them all. Okay, state the relationship between the number of carbon atoms per molecule and the boiling point of the fraction. Okay, so the higher the number of carbons, so as you can see, the carbon number is increasing. The higher the number of carbons, the higher the boiling point. We know this. And yeah, and they're mentioning boiling point there. So the greater, look at that, it's actually going a little bit better now that I've turned the camera off. The greater the number of carbons, shouldn't do that. If I was in an exam, I wouldn't. Greater the number of carbons. Yeah, it's a lot better. Look at that. The higher the boiling point. Notice, boys in the room, yeah, I'm not just giving very short. I'm giving this as a good quality sentence. I'm looking for that QWC all the time, even though it's not going to apply. I'm still looking for it. The higher the boiling point. Yeah, and I'm not going to do BPT. I'm not going to do my usual trick. I'm actually going to do it as if I was in an exam. There we go. Next. Oh, chromatography. Can I just say, if out of all of the questions that I always say are going to come up on your exam, folks, chromatography is going to be there. It comes up religiously. You guys have probably noticed this by now. They're there year after year after year. It's crazy. Okay, I'm actually going to struggle with one of these because this is on my laptop. I can't get a correct ratio. I can try. Explain which urine sample contains an illegal drug. Right, I'm assuming the urine samples are, the chromatography shows urine samples of A, B, C, and D, and 2 illegal drugs, Lasix and Boot. Yeah, Boot. It's weird. So, okay, which urine samples? So, number 1, do any of them contain Lasix? The answer is no. Oh, but C certainly contains Boot. Butte. Is it Butte? It'll be Butte, won't it? So it's C. And the reason being is, of course, they're on the same level. We're realizing that chromatography is actually a method for separation, but in GCSE, it's just a method of comparison. So, and explain your choice. So C, whoop. Sorry about this, folks. There we go. C contains, C contains, I'm actually going to put this, C contains Butte, due to dots have, I'm going to say, have same RF value. Now people are going to go, hang on a sec, RF value. There's no RF value here, but in reality there is. We're just going to say that they're on the same. I'm also going to then put comma on same level. Yeah, same level. And I would actually, in my exam, draw a dotted line across to it. Wow, it's so terrible at being able to draw straight lines today. Yeah, there we go. I would actually draw a straight line to it like that to show my working out. They can't take that away from me now because I've shown it. What is the meaning of the term solvent? It is the liquid part of a solution. The liquid part of a solution. There we go. Next, RF value. Right, calculate it. Right, now, just to tell you, you need to measure these in millimeters. Yeah, and it wants me to calculate the RF value for Lasix. And they give you the formula. I always love that about Edexcel. Did you know that no other sorry, my other laptop had gone into sleep mode. No other exam board give you that equation. None. All the rest of them just simply give you, they just ask you to calculate it. Whereas this one gives you distance traveled by dot, distance traveled by solvent. It tells you everything you need. So all you do, it hasn't told you it needs to be in millimeters. So I'm going to go, and it wants Lasix. So the distance, I'm now going to get my ruler out. Yeah, I'm going to place my ruler against this, and I'm going to line my ruler up with this, with that on 0, and then I'm going to measure to the center of the dot. Yeah, guys, this is important. Whenever you do it, you always measure to the center. I'm doing it in black. I'm going to switch to yellow so you can see it. I am going to measure. That didn't work. Let's try that again. No, laptop's having a couple of foibles today. There we go. So I'm actually going to measure from the center of the dot right there. Yeah, that's where I measure from. I don't measure from the top and I don't measure from the bottom. It's right in the middle. If they gave you a teardrop shape, yeah, you measure from the center of the circular head. Yeah, just to let you know, that's where you would measure from. And then you would just read this off in millimeters. Yeah, so I can't do this unless I had a piece of real paper. Then what I'm going to do is I use the ruler to do exactly the same thing, and I'm going to read off the solvent line in millimeters. Let's just make a guess. In fact, I can probably use the mark scheme for this. Yeah, that's probably quite useful, fair enough for me to do this. Yeah, they're really, really strict. The Lasix spot within 2 millimeters. Yeah, and the solvent dot has to be exact. In, again, there you go. They allow it in centimeters. Minimum of 2 decimal places. Yeah, or because it's in millimeters, you must give it to 2dp. So it's nice just to mention that. So that becomes 63 over 84. They give you no room for error on the solvent, none whatsoever. So you have to get it right. You have to make sure you got a ruler that actually gives it, because guys, I came across a whole lot of students that had rulers that didn't work. I kid you not, they were giving the wrong values, off by a millimeter, and they lost it. Yeah, that did happen once, so do watch out. So 62 over 82, was it? I don't know, 63 over 82, something like that. 62 over 84, amazing. So I got another 63 over 84. There you go. And then I get 0 point, and I get 2 decimal places on the end of it. And don't forget to write it on the line. Suggest how the solubility of the drug in the solvent affects the distance traveled. So the greater the solubility, the further it travels. Yeah, we know this. Greater solubility, the further they travel. Further drug travels. Not complicated, nice and easy. Next. Okay, question number 4. Lithium, potassium, and cesium. Wowzer, what a jump. Guys, I haven't seen cesium appear on a paper in a long time. Yeah, a small piece of each of the metals is placed into order as separate troughs. Complete the table, giving the correct metal. Explodes on contact with water, cesium. Yeah, fizzes gently, lithium. Reacts violently to form a lilac flame, potassium. Catches fire, nice one. Can I just point out, by the way, I'd also be really careful. It says, it's given names in the question. I would actually not want to give their symbols in an exam. I would want to actually write those out. I wouldn't want to risk it. Yeah, I just wouldn't. It's too risky not to write those down. Yeah, let's just do that. Far better idea. Next. Give the name or formula of the gas formed when the potassium. So the name is, of course, hydrogen. Can I just point out the level's getting slowly increasing. Formula, of course, is H2. If it said the word symbol, it would be H. But formula, of course, is H2. Any element that ends in gen or ene is diatomic. Give the name and formula of the compound when lithium reacts. So the compound this time. That's name is lithium hydroxide. Lithium hydroxide. And the formula, of course, is LiOH. So very reasonable. I'm wondering, where's the equation? They're going to ask you to put these together, aren't they? Come on, laptop. Come on. Think about it. It's thinking about it. It's going, I'm too slow. Oh, wow. I didn't click any. Oh, it's just kicked me off. Wowzer. Okay, folks, I think I'm still running. I think so. Holy moly. It's just decided just to kick me off, but don't worry, it won't take me very long to put it back on. There we go. Describe how you could show that that an alkaline solution is formed when cesium reacts with water. Right. Put a few drops of universal indicator in the water. Indicator in water. And it will turn purple. It will turn purple. You can alternatively use phenolphthalein and say it'll turn pink. Either one. Can I just point out that question usually varies between those two? Yeah, if it's phenolphthalein, you must say pink. If it's universal indicator, you must say purple. You cannot interchange those colors. Next, question number 5. Out of 15, we're doing all right. Right, into rates. Right, Irina, you're going to see these kick-ass questions arrive in a second. Okay, curve A shows the volume of carbon dioxide when marble chips are reacted with excess 1 molar hydrochloric acid, 1 mole per dm3. That was C. Let's label C, shall we? There's C. So this is the original. That's what they're telling us here. That's the ORI line. Yeah, the original rate line. And it then says, explain which curve, BCD, would represent the results obtained if half the mass of marble chips were used with excess acid. Right, that's interesting, actually. Half the mass. So it's going to be E. The only one it can be is E. Yeah. And the reason why is because if the acid is in excess, which it is, the marble chips are the ones that are going to stop the reaction. If I use half the mass, I'm going to produce half the amount. Well, I've produced 25 instead of, produced 30 instead of 60. So that's going to be E, and then you have to give your reasoning. Yeah, and you're going to say it produced half the volume of CO2. Yeah. Next, explain which curve represents the reaction performed at a lower temperature but with the same mass and excess acid. At a lower temperature than C. Oh, I'm an idiot. It was curve A. Sorry, my apologies. Easy to do that. But by the way, do you notice it came out in the wash? So that's my original line. Yeah. So at the lower temperature is C. C is going to be the lower temperature. Yeah. My phone's just beeped at me. The answer is C. Now, the reason why it's C is because if I'm using the same amount of acids and marble chips, I'm still going to get to the same amount. I'm still going to end at 60. However, it's going to be going slower, which it is. How steep at the beginning it is it's less steep. Yeah, because it's so the rate. Remember that this section here is the rate. Yeah, there's the rate. So I've lowered the temperature, so we can go for the original line as that's the rate of A, and then the rate of C is this. Yeah, so that's now they've lowered the temperature. Yeah, that's hot. Let's make this warm. Yeah, we've lowered the temperature. The rate's got less. It's taken longer to finish. Yeah, loads of reasons, but we get the same volume. So that's a shift in temperature. So that was going to be C. Explain your answer. You're going to say because the rate of reaction, the rate is slower. The initial rate is slower. I know this due to less steep line at start. And also the reaction takes longer to finish. It takes longer to finish. It's loads better since I turned off the camera. Loads better. It's actually responding the way it should have been. Next, explain which curve B, C, or D represents the obtained when marble chips were replaced with the same mass of powdered. Wowzer. Powder's going to go a lot faster, folks. A was the original. A was the original. Yeah. And we've now done powder. So it's going to be B. Yeah, B is much faster. Now, people are going to say, why is it not D? Because we added the same amount, the same mass of limestone. If you'd added more, yeah, we did when the same mass, but we just powdered it, which means the same mass means I'm going to still make the same amount, but I'm going to make it faster. So that line is going to be B is the line for the powdered. D, they've added loads more. They've doubled the mass. Yeah, and that was B. And that's because rates increased, same amount produced. Yeah, rate has increased. Rate increased / steeper initial line, but finish it, but same amount produced, but same vol of gas produced. Hope that makes sense. Any questions, anybody at this stage? If you've got any questions, just give me a shout. Suggest a suitable piece of apparatus for collecting it. A gas syringe. That's the only answer. A gas syringe. Yeah, gas syringe for collecting gases. That would really be the only piece of apparatus you would ever use for collecting gases. Don't say a balloon. Right. Question number 6. Solution of lead nitrate and sodium chloride. Oh, they're forming lead chloride. I think lead chloride's white. I think. Right. Suggest why the height of the precipitate eventually stops increasing as more lead nitrate is added. Oh, okay. So they're adding, what they're doing is they have a beaker. Let's just draw that out. And I get that from the question. They've got a beaker containing sodium chloride, and they're adding the lead nitrate to it. Now, the lead nitrate, of course, is going to form a precipitate, cause a precipitate to form. Yeah, and that precipitate, we know that precipitates always sink to the bottom. So as it adds the lead nitrate, it'll sink, allow the precipitate to settle. There's that bit. Measure the height. And they're adding more and more lead nitrate and seeing the precipitate increase until eventually it stops. And it stops. Height of precipitate 2.5. Interesting. And then drops back down again. Oh, it's an anomaly. They've measured it too soon. They didn't wait for it to settle enough. Suggest why the sodium chloride's all been used up. NaCl has been all used up. Has been all used up. Has been used up. Yeah, none left. None left. Won't get anything else. Yeah. Tom, could you say the rate increases due to the increased surface area while the mass has stayed the same? Oh, Tom, what a great question. I'm so glad you asked that. Okay, do you know what, Tom? No, I don't think you can. That's a really, Tom, I'm really surprised that I missed the chance of talking about that. The reason being, Tom, is they're not asking you. They're just saying, explain which curve could represent. They're not asking you to explain why the rate increased. They're not asking you to do that. They're asking you to explain how you know that the curve was for that one. Oh, I've got to check the mark scheme on that now. That's a really good point. pH meter. Add red, accept any name, didn't accept the correct name, and ignore purple. Accept color, correct color for named indicator, ignore purple. That's weird. Oh, they're saying for the red litmus paper. Yeah, okay. No, universal and purple is correct. Absolutely. Volume of carbon dioxide gas is half that. Curve levels off. Curve is less steep. B, curve levels off. Like, ignore reference to collision theory. There you go, Tom. Tom, I'm so glad you asked. This question is asking you to explain how you know which line is which. And that is based on your understanding of what these lines are showing. Remembering that this is all rate graphs. Just going to quickly do the rate. This is, because having 6 on the line like that. So this is your rate graph. Your initial rate, this is the fastest section. The linear section there, that bit there is the fastest bit. That's what you always talk about, how steep it is. Yeah, then you talk about the time it takes to finish. This is the point when it stopped. That has ended, reaction's over, and now it's slowing down due to particles being used up and concentration decreasing. And then you apply kick-ass, Arena. Yeah, I'm sorry that kick-ass never arrived, by the way. They've been asking you about graphs yet, although I do feel like it's not over yet, but we'll see. Okay, next. I hope that helps, Tom. Good question. You can't. You've just got to explain how you know from the graph. It's a description of the graph lines. God, I'm really sorry about that. I did that without even thinking about it. Tom, I really needed that question. Thank you. I really appreciate it. Right. Plots the results on the grid. Okay. So he's just going to plot, he's plotting a graph. That's quite nice. And all the lines of it, this is 4 marks. What? Plot a straight line through the origin. Draw a circle on the grid around the point that represents the anomaly. What the heck? 4 marks for that graph. Make sure that the 2 lines cross. Okay, right. Oh, I see what's going on here. There's 2 bits, isn't there? Oh, that's not very nice. Hang on a sec. Hang on. Plot the students' results on the grid. Draw a straight line of best fit of the origin for the first 3 points and another straight line of best fit through the last 4 points. Make sure that the 2 lines cross. Right. 2, 4, 6, 8, 10, 12, 14. Okay. Cool. So we'll point at each bit. And it goes 0.6, 1.2, 1.8. 0.6, 0.6, 1.2, 1.2, 1.2, 0.6, 1.2, and 1.8. Right, that kind of makes sense, doesn't it? Straight line through it. Eek, it's a terrible cross. 0.8, there we go. Ruler. Wow. Do you know what? Tablets are great to a certain extent, but sometimes they don't half do some garbage. It's really stupid. Won't let me do a line where I actually want to put it. Okay, ruler. Sorry, I have got to do it freehand. Best I can do, I'm afraid. Right, last two, 8, 2.1, 2.5, 2.1, 2.1. Okay, so 2.1, 2.5, 2.1, 2.1. Wow, that's interesting. And it then says, draw a line of best fit through the last 4 points. Oh, okay. Make sure the lines cross. I can see what they're doing. Last 4. Ignore the anomaly. You ignore this, folks. Ignore it. Wish my laptop would do what I am asking it to do today. Yeah, that one's at 2.5. I'm going to ignore it. Yeah, straight line. Sorry, my ruler doesn't work on this stupid thing. Yeah, straight through. I like it. Where the 2 lines meet and then the anomaly. Okay, I like it. 4 marks. That's the best 4 marks I've ever seen. Wowzer, for a graph that much, that's amazing. Yeah, make sure the tune's fine. Draw a circle on the grid around the point that represents the anomaly. Can. Yeah. Which statement is a possible explanation for the anomalous result? The precipitate was not allowed to settle before its height was measured. Absolutely right. I'd agree with that. Only 1 centimeter of sodium chloride was added and not 2. Oh, this is quite interesting. You have to consider each one. The answer is going to be A, by the way. But because let's just consider each one. They were adding 2 centimeters of lead nitrate, and they were adding sodium chloride. Place 15 centimeters cubed of sodium chloride in the test tube. Right. So they then added only 1 centimeter of sodium chloride was added instead of 2. That doesn't even make sense. They added 15 centimeters cubed. It makes no sense whatsoever. Yeah, it makes no sense. So that's complete garbage. Never seen one that's quite as wrong as that. 20 centimeters of lead nitrate was added. Would the 20 centimeters make any difference? We added 2 centimeters of lead nitrate. If we add 15, we're still gonna the sodium chloride. They're adding more and more lead nitrate. If they add, notice once they've got to 14, it's leveled off. It makes no difference if you add any more. It should give you the same value. Yeah, the reaction was carried out at a higher temperature. No, because it would make it quicker, but you wouldn't make any more. So the answer is A. The answer is A. Why should the graph line pass through the origin? Oh, great question. Why is it directly proportional? Because if 0 centimeters cubed of lead nitrate, if 0 centimeters cubed of lead nitrate, lead nitrate is added, you will get 0 precipitate. We will get nothing. So it's a question. Isn't there a ruler feature on OneNote, top right hand corner? Oh yeah. Oh, Irina. Oh, you're my new best friend. Oh, this is the best thing ever. Oh, I never knew this. Oh, this is the best thing ever. Oh, my world has changed. Irina, thank you so much. That is awesome. You've just made my day. Absolutely made my day. Look at that. Ho ho! Irina, you are just a little gem. That was amazing. Thank you so much. Oh, it's my new best friend. Thank you. 3 commendations right there, Irina. Next, use the graph to estimate the volume. That would have been easy to miss, wouldn't it? Use the graph to estimate the volume of lead nitrate solution that would have reacted with the 15 centimeters. Right. Right, what's that? So there's 2 between these 2 lines. So this is going to be, so that would 2. So that's going to be 7. So 7.2, is that right? So I've got 6.2, 6.4, 6.6, 6.8, 7. 7.2, 7.2 centimeters cubed. Do you know what? Isn't that strange? I want to check that. Yeah, let's check it. I want to check what they wanted for that. I like it. 7. Oh, accept values between 6.8 and 7.2. Oh, it was close. It was so close. So close. They wanted it to be dead on 7. Okay. Interesting. So my line's not perfect. I'm on a tablet. 7.2, still got it, just about. Alkanes are saturated hydrocarbons that we can obtain from crude oil. Oh, I hate that definition, you know. A compound that does not contain carbon double bonds. Isn't that a nightmare? It's a does not definition. I hate, because unsaturated is easy. It contains carbon, a compound that contains carbon double bonds. But this is a does. I hate that definition, folks. Carbon double bonds. Yeah, saturated means it's like it's an alkane. Does not contain carbon double bonds. There we go. What is the meaning of hydrocarbon? A compound. You need the word compound. A compound that is made from only carbon and hydrogen. Yeah, easy enough. Done. Pentane is an alkane with 5 carbons. What is its molecular formula? Double it and add 2. There we go. Nice and easy. We're doing all right. We're at 47 minutes now. I have no idea what question I'm on. Questions are getting longer, of course. Octane is an alkane present in petrol. When octane burns completely in oxygen, carbon dioxide will write the chemical equation for the... Wow, look at the state of that. Why is it given such a big size? C8H18 plus O2 goes to CO2 and H2O. Right, and don't forget to balance it. 8 carbons, 18, 9, right, 16 plus 9, 25. It would actually require 12.5. I don't like it. Yeah, I'm going to double everything. 2, 25, 16, and 18. There we go. I'll check it as well. It only takes me a minute. Yeah, 16 carbons, 16 carbons. 36 hydrogens, 36 hydrogens. Oxygens, 50. I've got 32. 32 plus 18 is 50. And I'm golden. Done. Next. Give the name of a toxic gas that may be carbon monoxide. Carbon monoxide. There we go. Dodecane is another alkane. When heated and passed over a suitable catalyst, it decomposes the catalyst to zeolite or aluminium oxide. I hate. It's called zeolite. Yeah, it decomposes to form octane and one other hydrocarbon. Show how a catalyst increases the rate. How? State how. You guys have all had this question. Catalysts have 2 questions. What is and how it functions. Yeah, it provides a catalyst. Zoom in, why not? A catalyst provides, because this is state how it does it, yet a catalyst provides an alternative reaction route with a, notice my capitalization, with a lower activation energy. Done. Give the name of a suitable catalyst for this process. So Edexcel, in their infinite wisdom, want you to just say aluminium silicate, I believe. It's name, aluminium silicate. But I'm actually going to put brackets zeolite. Yeah, that's what I want you to know. Let's just check the mark scheme on that. It's nice here. Even I want to check them. All carbon-carbon bonds are single, no carbon-carbon double bonds. Compounds only, I like it. C5H12. Balanced. Oh, look, they allow the half. Shocking. They'll accept multiples. Carbon monoxide. Silica, silicon dioxide, alumina, aluminium oxide, except alumino silicate, except zeolite. Woo. Ignore silica oxide, ignore alumina oxide. Yeah, fair enough. Aluminium oxide. Except alumino. That's what? They've aluminium. What? Just go for zeolite. Just do zeolite, folks. Yeah, I've given both, so they can have it. Whatever. They're garbage. They're rubbish. Edexcel, idiots. Complete the equation that represents the reaction. Oh, they were doing cracking. What was it said? It was going to octane and one other hydrocarbon. Oh, they've already balanced it for me. That's clever. C8, C12. I am missing 4, but I need to be split it into 2. So C2. Next, 26 went in, 18 came out. I am missing 8 divided by 2. H4, ethene. Next, name the other hydrocarbon produced. Ethene. Yay. Next, are into flame tests at this point. It's gonna be interesting. We're about halfway through it at the hour point. Suggest 2 reasons why platinum is a suitable metal. High melting point. High melting point. Unreactive. Unreactive. Yep, nice and easy. Why should the platinum wire be cleaned before each test? To remove any contamination stroke from previous tests. Yeah, I like it. Why is a luminous flame not suitable? Luminous flame is the yellow flame. Yeah, you can't do it because you'll just see yellow. Yellow color of flame will mask any flame colors. Next. Okay. Oh, I've done a load of tests. I like it. Okay, so give the name of compound X and compound Y. So compound X, yellow flame test, Na+. White precipitate with acidified silver nitrate, Cl-, none and none. So that now is name. Sodium chloride is X. Yeah, next. Y, red flame. Red is lithium 1+. No precipitate. White precipitate barium chloride, SO4 2-. Name lithium sulfate. Wow, can I just point out, folks, if you put formulas in the air, that would be devastating. You would lose 4 marks on that. God, make sure you don't do that. That'd be a horrendous. That's almost a boundary. Scary. Identify the ion, the cation present in C. Cation, green precipitate, sodium hydroxide, Fe2+. It says identify, so I can give a formula or the name. If I was going to actually give a name, I'd say iron 2+. Yeah. I would just put the formula though of Fe2+. Describe a chemical test other than heating that could be used to show that other than heating. Oh, yeah, decompose it, I guess. Add acid. You're going to need to name one. You can't just say add acid. It's going to be add, I don't know. Let's just do the normal one. Hydro, and you know what? No. Add dilute sulfuric acid. That's what I'd do. If I was actually going to do it properly, sulfuric acid. Wouldn't use concentrated, that'd be madness. Yeah, and the results is I will see effervescence. Yeah, results, fizzing, bubble gas through lime water, bubble gas through lime water, it will turn cloudy. It'll turn cloudy. Now, can I just say, at this point, guys, I keep seeing Edexcel ask for that equation for the lime water test. Just be warned. So the lime water test, lime water is calcium hydroxide in aqueous. And if you add CO2 to it, you form limestone, which is insoluble, and water. Yeah, that's the lime water test. And the reason why it goes cloudy is because you're forming solid limestone. I'm just warning you, that equation keeps coming up, and I'm just wary of it. Okay, I'm at question 9. I'm halfway through. I'm going to do one more question, and then I'm going to end the webinar there, and then I'll pick this up tomorrow. I'm going to finish this off tomorrow at 12 o'clock. State the color of chlorine gas. It is green, I believe. Yeah, now this will be interesting. I want to check the mark scheme now for that, because I've seen Edexcel call yellow on that one, and I don't like it. Sodium chloride, lithium sulfate, iron 2, add dilute acid, yet gas, test for the gas turns milky. There you go. Whew, if you just said fizzing, you'd have lost loads of mark there. Green, ignore shades, except yellow green. They allow yellow green, but not yellow. Watch out, chlorine is a green gas. It's like the Hulk. Anyway, suggest why it is necessary to have an open tube fitted to the apparatus. Yeah, okay. Guys, if you notice, you're going to pump in a gas here. And if that was sealed, yeah, the pressure inside would increase until the whole thing exploded. Yeah, so you need to have a vent to allow excess chlorine to escape so that the pressure doesn't increase. Yeah, this is to allow excess gas to escape, preventing pressure buildup. Possible explosion. Want to see a mark scheme for that? Definitely. Oh, to allow excess gas to escape to prevent pressure buildup. Look at that. Winner. I'll take that. Thank you very much. Winner. For safety reasons, this reaction should be carried out in a fume cupboard. Explain why. Chlorine's toxic. We're done. That's easy. Chlorine is toxic. Just to say, if they actually said that, and they said, give a second reason, you're forming iron chloride. Guys, that's toxic as well. It's a powder. The powder seems to be sticking on the glass, which is a bit weird in my belief. It's going through vapor deposition. Very clever, actually. But you're still going to have a small amount of iron 3 chloride escaping. Iron 3 chloride is toxic. Any heavy metal compound is toxic. Do they accept that? No. The gas is toxic, poisonous. That sucks. It's sucky. Next. Right, a good old calculation. A mass of treatment reacts with that of chlorine. Calculate the empirical formula. Right, empirical, straight into Fe and Cl. Turn the percents to grams. Oh, they've already done it for me. Why, thank you. Do you notice the 3 decimal places? Very strange. 5.325. Right, percent to mass. Mass to moles. Over 56. Over 35.5. I'm counting atoms in empirical formula, remember, folks. Atoms. Not molecules, but atoms. So I'm just dividing them by their atomic masses. 2.8 divided by 56 gives me 0.05. Surprise, surprise. 5.325 divided by 35.5 gives me 0.125. Divide them all by the smallest. 0.051, 0.053. Empirical formula, FeCl3. I'm done. Suggest the name of this compound. Iron 3 chloride. The trick there, folks, is who's going to have forgotten the 3? Yeah, you've got to do it. Iron 3 chloride. Very easy to miss the number. If that had been a 2, it would have been iron 2 chloride. When chlorine gas is bubbled through aqueous sodium hydroxide, a mixture of bleach and sodium, write a chemical equation. Right, so when chlorine gas is bubbled through sodium hydroxide aqueous, a mixture of bleach, NaClO, sodium chloride, and water are produced. Balance the equation. 2 chlorines, 2 chlorines, 2 sodiums, 2 sodiums, 2 oxygens, 2 oxygens, 2 hydrogens, 2 hydrogens, and I'm done. Clever question. People freak out. Don't. They're telling you exactly what you need to do, folks. That's nice and easy. Yeah? And that's the end of question 9. Look at that blank page. So I'm going to finish. End of part 1. Yeah, look at that. Lovely. I assume that takes me into the next question. Number 10. Amazing. Oh, right. So now what I've got to remember to do is I have to reactivate my camera, don't I? Device manager. That's quite funny. Oh, it's thinking about it. Hey guys, sorry. I'm now start cam. Wait, I'm back. Hey guys, right. I've done the webinar. We're on an hour and 2 minutes. I'm going to leave it there today. We're halfway through the paper. We're at question 10 out of 15. In fact, we're 2/3 of the way through it. So I'll pick this up tomorrow at 12 o'clock if you want to come along. I really hope to see you there. Irina, have a look at go through my channel or go through the document. You've seen the document. You've got the document, right? Go on to that. Go to rates of reaction and then click on my webinar and it'll talk you through kick-ass. You should also do coughs for equilibrium as well. Right. I'll see you guys soon. Have a great rest of your day. I'll see you soon, guys.